Okay, this video is meant for my Algebra 2 students. We have a quiz coming up tomorrow, which is Thursday, over 6-1 through 6-4, and this is a YouTube review to get you ready to go. I got about 11 questions. I mean, your thing has 20 questions on it, so these 11 questions, I mean, that's half the quiz, so, pay attention, and make sure you bring this in for your bonus point. Alright, number 1 here. Find all the real fourth roots of this number, 10,000 over 81. Okay, and remember, when they ask you to find the roots, there's no radical here, but I need to put this number underneath a radical. So this would be radical 10,000 over 81. And if they're asking me for the fourth roots, that means that the index is a 4. And if your index is even and you bring a radical into the problem, there are going to be two answers, plus and minus. That's because of the even idea. Okay, now remember, if this number were negative inside this even index, you cannot do the problem, okay? But because this is a positive number inside an even index, we're good to go. So, is 10,000 something to the fourth power? Is 81 something to the fourth power? Well, use your calculator. Okay, try some numbers. I bet you guessed 10,000. 10,000 is 10 to the fourth. 81 is a little bit tougher, but you don't have to go very far. Is it 2 to the fourth? No, that's 16. Is it 3 to the fourth? Yes, it's 3 to the fourth. So inside this fourth root, I have 10 to the fourth and 3 to the fourth, so therefore the answer is plus or minus 10 thirds. The 10 and 3 come out, nothing's left inside. Done. Okay, next. We have a simplify question. This is a cube root of 54y to the 10th. We need to pull out all of the perfect cubes. So the first thing I will do is I will break down 54. And let's do it right here. Now, what times what gives you 54? Well, maybe you think 9 and 6, right? That's the multiplication fact. If you don't, start small, 2 and 3. Start with 2, start with 3, try something. I'm looking for perfect cubes. 9 is 3 squared, which is 3 and 3, right? I want perfect cubes. I want something 3 times. 6 is 3 and 2. Ooh, I love it. 3 3's make 3 cubed. This is a good thing. This 2 has to come as well because it helps make 54. There's 54. 3 cubed and 2. So when I do this simplification problem, the cube root of, I want to write things as perfect cubes. 54 is 3 cubed times 2. And then these y to the 10ths, write them as y to the thirds as many times as you can. Y to the third. That leaves me with 7. Y to the third. That leaves me with 4. Y to the third. That leaves me with one more y, and you just write that one last y. Right? Because 3, 3, 3, and then this is a 1. 3, 3, 3, and 1 make 10. And that's what you have to make sure happens. So now anything cubed comes out. Anything not cubed stays. 3 comes out. 2 stays. Y comes out. Y comes out. Y comes out. Y stays. So because things are staying, you have to keep the cube root, and the 2y comes after. And then out here, just make sure you multiply, right? Y, make y to the third. 3y to the third cube root of 2y. And there you go. So that's how you simplify this cube root. Next, we're going to do a multiplication problem here. Multiply these two square roots. Well, since they are the same index, right, I'll put it in red here. We have a 2, let's do it in blue. I have a 2 and a 2 as the index. I can combine these into one radical, square root. And when I do this, I'm not going to combine the numbers. 8 times 40, but I will combine the y's. I have 5 y's and 2 y's, that's 7 y's. Okay. And now to the side, I'm going to fix the 8 times 40. Let's do it right down here. I am looking for perfect squares. Okay. So however you have to do it. Now maybe you can think like this, and this is the best way to think. What makes 40? 8 and 5. That's the best way, because now look. 8 and 8 make 8 squared. And then this 5 has to come. So be aware of this. That you should look for the simplest way to get your perfect squares. Sure, you can break 8 down into 4 and 2, 40 into 4 and 10. Sure. But you just have a lot more things squared versus looking for the biggest numbers that go into it so that you can maybe get those two common numbers to make a squared. Okay, so just be careful. That's what makes these problems difficult and challenging for us. So inside this square root, we are going to have 8 squared times 5. That's the 8 times 40. And then again, y to the 7th, how many y squareds, right? How many y squareds? Well, we have y squared, that's 5 left. Y squared, that's 3 left. Y squared, that's 1 left. Write down that y of the first. And again, 2, 2, 2, and 1 makes 7, so we're good. Anything squared comes out. 8 comes out. 5 stays. Y comes out, y comes out, y comes out, y stays. So because things are staying, I have to have my square root. And again, just simply multiply things that need multiplied. Y, and y make y to the third. 8y to the third, square root of 5y. So remember, when you multiply, you need the same index. So maybe I'll put that right here. Multiplying, you have to have the same index. Okay. Next, 4. Here we go. It says rationalize the denominator of each expression. So this is division. Okay. So really, what this says is divide. Right? It says divide. So when you're dividing, again, the indexes must be the same. And we do. This is a 2, that's a 2. So I can write this as one big radical. Square root of 3x y squared over 5xy cubed. And the reason that I do that is because things are going to simplify. Excuse me. The 3 and the 5 do not change. So 3 on top, 5 on bottom. We have an x on top and an x on bottom. Those x's go away. I have y squared, which is a y and a y. I have y cubed, which is a y, and a y. 2 of them cancel. So this y squared is gone, and now this y cubed remains as just a y. So there's a y on the bottom. So see how taking the 2 radicals and combining them into one first will be very helpful, because it will simplify these problems to a point where maybe they're more manageable. So now that this is simplified, now break it back apart. Square root of 3 over the square root of 5y. And now it's time to do this thing called rationalizing. And to rationalize, what that means is get rid of the radical on the bottom. To get rid of this radical on the bottom, this 5 would have to be squared, and this y would have to be squared. So multiply this bottom by the square root of 5y, because that'll make the 5 squared and the y squared. Now, with fractions, if you do something to the bottom, you do it to the top as well. So in the top, we get the square root of, I'm just going to write them next to each other, 3 times 5y, and on the bottom, I get the square root of 5 squared and y squared. In the top, nothing's going to simplify, so just multiply that out. That's the square root of 15y. But in the bottom, the 5 comes out and the y comes out. There's nothing left inside the radical. This 15y is inside the radical. This 15y is outside. They cannot be touched. There is your final rationalized answer. Okay, so those are very tricky. So hopefully you have, you remember this example, have the ones from your notes. Those are very, very tricky. Okay, number 5 here. We're going to simplify this problem. And this is really a subtraction problem, right? Subtract. Now, in order to add and subtract, you have to have the same index, but you also have to have the same radicand. Remember, that's the number inside the square root, right? That's this number. And the index is here. So if we look here, this is cube root of 81, this is cube root of 54. They're both cube roots, but they have different radicands. So we must fix that. To fix that, we need to simplify. Okay, so we're going to look at the cube root of 54 first. I need 54 to be broken down. Now remember, we did it earlier. But again, maybe you do again 9 and 6, and 9 is 3 and 3, and 6 is 3 and 2. So these 3 3's make 3 cubed, and we have a 2. Okay? So I'm going to put the 2 with the cube root of 54. So the 2 cube root of 54, that's just taking it right from the problem, equals 2 cube roots of, and inside the cube root is 3 cubed times 2. Right? That's the 54. 3 comes out. So the 2 is already outside. This 3 comes out. This 2 stays. Cube root of 2. And 2, cube root of 54, simplifies to 6, cube root of 2. Okay, so now we're going to take a look at this problem here, and I'm actually going to change this 81 because this problem actually would not work out right. So I'm actually going to change this to a 75, okay? So now we're going to take a look at the 3 cube root of 75. And again, the radicands are still different, so we're going to break down 75. And I'll do that here in green. Oh, I'll do it in blue. Okay, so the 75 here. Now, if I know that not 75. We're going to go with 250. I'm sorry, this problem is all messed up. This is a 250. I apologize for this. So this is a 250. We're going to go with a 250. Okay, and when we break down 250, understand that 2 must remain inside the cube root. So 2 should be one of your factors. So 2 and what make 250? Well, that's 125. And 125 is going to be a perfect cube. It is 5 cubed. Again, maybe you could guess that. So 5 cubed and 2 make 250. So this 3 cube root of 81, do it right here. I'm sorry, 3 cube root of 250. What am I doing? 3 cube root of 250 is really 3 times the cube root of 2 times 5 cubed, which is 3 times the 5 comes out, the 2 stays inside, so we have to write the cube root of 2, and this is 15 cube root of 2. So now, this problem, the original problem, really boils down to this and this with a minus sign. 15 cube root of 2 minus 6 cube root of 2. Okay? And again, the reason I had to change that radicand to that 81 is because the radicands would not have come out to be the same. So I want to make sure this reflects what's going to be on your quiz. So the radicands will come out to be the same. And now, when the index and radicands are the same, you can combine the coefficients, the numbers on the outside. 15 minus 6 is 9. The cube root of 2 does not change. Okay. So again, sorry about the confusion. This is a very important problem. Review the one from your notes as well. But I believe these are very important problems. Okay. When you add and subtract, got to make sure the index and radicand are the same. Okay, next here, we're going to multiply these two binomials. And notice they have some radicals involved. So we're going to do this by distributing. So 3 times 5 is 15. 3 times negative 6 radical 2 is negative 18 radical 2. Notice the 3 doesn't touch the radical 2. And now we do the negative 4 radical 2. Times 5 is negative 20 radical 2. Again, the 4 doesn't touch the radical 2. The 5 doesn't touch the radical 2. And then we do negative 4 radical 2 times negative 6 radical 2. That's positive 24. 4 and 6 is positive 24 because they're both negative. And then the 2 radical 2's make a radical 2 squared. Okay? And now, this radical 2 squared is really just a times 2. The 2 pops out. So really, I want to rewrite this problem as 15 minus 18 radical 2 minus 20 radical 2 plus 48. 24 times 2. And now we combine. 15 and 48 make a 63. Negative 18 radical 2 and negative 20 radical 2 is negative 38 radical 2. And there's your simplified answer. Okay, halfway there. I know this is a long video, but it's a very good review. Maybe I'll make this worth 2 points because it is such a longer video. Okay, shh, don't tell anybody. Alright, it's your little secret. You get 2 points now. Okay, so we're going to rationalize this denominator. 4 divided by 1 plus the square root of 3. And in order to rationalize this, we must multiply by the conjugate of the denominator. 1 minus the square root of 3. And if I do it on the bottom, I have to do it on the top. Okay? So when we do this, we are going to distribute or we're going to FOIL. In the top, this 4 is going to go to both. So in the top, we get 4 times 1, which is 4. 4 times negative radical 3 is negative 4 radical 3. In the bottom, we're going to FOIL out this 1 plus radical 3, 1 minus radical 3. So 1 times 1 is 1. 1 times negative radical 3 is negative radical 3. Radical 3 times 1 is positive radical 3. And positive radical 3 times negative radical 3 is negative radical 3 squared. So the top stays the same, 4 minus 4 radical 3. They do not combine. But the bottom, this 3 comes out of the radical to become 1 and then a minus 3. And this negative radical 3 and this positive radical 3 cancel. So this is really just 1 minus 3. Okay? So I will simplify that bottom. So we have 4 minus 4 radical 3 over, and 1 minus 3 is negative 2. And now we divide each of those by negative 2. 4 divided by negative 2 is negative 2. Negative 4 divided by negative 2 is positive 2 radical 3. And there is your simplified answer. Okay. So remember, the conjugate is used to rationalize a square root in the denominator. Make sure you remember that. And again, when you do that, the radical should disappear. And all that you're left with is some nice numbers. Okay. Alright, so let's take a look at what's next here. Number 8. Got to scroll all the way back to the beginning. Number 8 now goes into section 9.4. Okay? And again, I think that's it's the weirdest section. These rational exponents are difficult. Okay? Alright, so here we go. Simplify the expression. And I'm going to rewrite it so you can see it, because that's hard to see. This problem says 7 to the 1/2 times 21 to the 1/2. Okay. Now, since these two big numbers are different, let's use radicals. Use radicals. Because the exponents are the same. So when I write this in radical form, I think I'll be able to multiply them. Remember that the denominator is the index. That's the index. The top number is the power. Now, we like it when there's a 1 on top because that really doesn't affect the problem. So this is really the square root of 7 times the square root of 21. Okay? And because these are the same indexes, we can multiply. That is the square root of 7 times 21. And again, don't multiply it out. Let's write it next to each other, and let's try to simplify. Again, remember, 7 is a prime number. It can't break down. But 21 is 3 and 7, or 7 and 3 for my case. So that's 7 and 7 makes 7 squared. This square root of 7 times 21 is the same thing as the square root of 7 squared times 3. And anything squared comes out of this square root. 7 comes out, the 3 stays, so it stays inside. 7 square root of 3. And also remember, when you pull something out of a radical, the exponent does not come with it. So like that 7 squared, only a 7 came out, not the squared. Keep that in mind. Okay, next. Rewrite this in radical form. So this is just a simple, can you write it in the other form? And here's the original problem. Y to the negative 9/8. And there's two things. Number one, there's a exponent rule, and that is a negative exponent rule. A negative exponent means you take the reciprocal. So this y to the negative 9/8 becomes 1 over y to the positive 9/8. Okay? And now again, the bottom number is the index, the top number is the power. 1 over 8th root of y to the 9th power. And that's how you'd rewrite that in radical form. Okay? So be aware of those negative exponents. They're pesky. Okay? They're pesky. All right, here you go. Number 10. We need to find the product, right? This is multiplication. Well, look here. Square root of 5, 5th root of 5. Different indexes, right? These indexes are different. Different index. So really, we couldn't do this problem, but wait. Let's use rational exponents. Okay? Let's rewrite these in rational exponents. There is a hidden 2 right here. So this square root of 5 can be written as the 5 to the 1/2. And this the 5th root of 5 can be written as 5 to the 1/5. And now, because these two 5s are the same, we're going to get 5 to a single power. And to do that, we're going to take these two exponents and we're going to add them. So we're going to take on the side here, I'll do it right here, 1/2 plus 1/5. And to do this, we need a least common denominator. Your LCD is going to be a 10, because that's the smallest number I can make, 2 and 5. So times 2 by 5, times this by 5, times that by 2, times that by 2. We get 5 over 10 plus 2 over 10. And that is 7 over 10. And that's your exponent. So this 5 to the 1/2 times 5 to the 1/5 is 5 to the 7/10. So just be aware when your indexes are different, use rational exponents, and then we're just going to multiply those, or not multiply, I'm sorry. We're going to add those exponents together. Okay. The confusion is sometimes people multiply, but when you're multiplying, these are called like bases, the 5 and the 5. When you're multiplying like bases, you add the exponents. Remember your exponent rules are in that box. When you get your notes for the quiz, make sure you use that to your advantage. Okay. All right. 2 more to go. Number 11. Here we go. We're going to divide. Okay? And the same kind of problem here. If you notice, these are different indexes. 6th root and 3rd root. Different indexes. Use rational exponents. Okay? So this is going to be 4 to the 1/6 over 4 to the 1/3. Okay? And now you are dividing like bases. And when you divide like bases, you are going to subtract these two exponents. Top, 1/6 minus bottom, 1/3. 1/6 minus 1/3. And the nice thing here is your LCD is actually going to be a 6. I can make 3 become 6, so don't touch the 1/6. But now multiply the 3 by a 2, top and bottom. And 1/6 minus 2/6 is actually negative 1/6. Okay, so this is the exponent of your 4. 4 to the negative 1/6. But remember, we don't like negative exponents. Negative exponents means you take the reciprocal. 1 over 4 to the positive 1/6. And there's your answer. So again, these exponent rules are very, very tricky. Okay, so just try your best. Right, that's all you can do. Okay, and then number 12 here. We're going to write this expression in simplest form, okay? And I'll rewrite it right here so you can see in blue. This is x to the 1/2, x to the 1/2, y to the negative 2/3, all raised to the negative 6th power, okay? And what you do here is this negative 6 actually gets distributed to those two exponents, and when you do that, you're actually going to multiply them, okay? So over here, I'm going to multiply 1/2 times negative 6. Put that as a fraction. And when you do fraction multiplication, you do not need a common denominator. Just go tops and bottoms. 1 times negative 6 is negative 6. 2 times 1 is 2. This simplifies to negative 3. And hey, I like that. It's a negative, but at least it's a whole number. I'm sorry, it's an integer, right? It's just a negative number. So x to the negative 3rd. And we'll do the same thing with the y's exponents. Negative 2/3 times negative 6. Put it over 1. Again, multiply straight across. That is going to be negative 2 times negative 6 is positive 12. 3 times 1 is 3. 12 divided by 3 is 4. Y to the 4th. And now we have to fix this negative exponent. I like that y. That y is to a positive power, so that stays the same. But this negative means reciprocal, right? So the y to the 4th remains where it is, but move the x down to the bottom. Y to the 4th over x to the 3rd. And there's the simplification of that problem. Okay. All right, so again, sorry for the long YouTube. Again, it'll be worth 2 points now, so hopefully you did it because it was a lot of work. And, happy studying. We'll see you on Thursday.